Okay, Dr. Brian Mowll, the diabetes coach, and I am back today with Dr. David Perlmutter, who we've had on before, an amazing speaker, author, lecturer, scientist, physician, and someone that I've looked up to for many years, learned a great deal from. So, Dr. Perlmutter, welcome back.
I'm so delighted to spend time with you. It's great to see you again. And, we were just talking before we went on about, how great it's going to be for everybody to get back together again. Looking forward to that.
Yes, hopefully one day soon. So you have a new book that I am dying to talk to you about, all about uric acid. It's called Drop Acid. So if people watching this, I'm just going to say it right here at the very beginning. If you don't have the book, I would highly recommend picking it up and reading it. I think it's an important topic that really does not get nearly the amount of attention that it should get. So hopefully we're going to give it some attention today, help people understand what uric acid is, when it's, a marker of problems, and what we can do to support the body in metabolic health and the connection there between uric acid and insulin resistance and type 2 diabetes and all these things, amongst other problems. So just off the bat, what is your interest in uric acid? This is a sort of you've written books about the brain largely, and this is, obviously you can draw some lines here to, and I'm sure you will, to connect the dots, but why uric acid?
Well, I think you already led into it, and that is I am interested in the brain. I'm a neurologist, and I've been puzzling over why does a good brain go bad? That question for an awful long time. As a neurologist, I was pretty well trained to treat symptoms. Really, it was pretty much in terms of helping people, a kind of a diagnose and adios kind of scenario where, yes, we would treat symptoms, but we sure wouldn't have anything to do with the underlying causes of the various important neurological maladies like Parkinson's and Alzheimer's and MS. And I was never satisfied with that. I wanted to know why people had these problems and what, importantly, people could do on the front end to help restrict their risk for getting things like Alzheimer's. What I'm opening up right now is this topic of Alzheimer's prevention. Who knew? And there's such little interest. We have a heart healthy diet and heart health awareness month and all this stuff, cancer prevention, this and that. But, as it relates to Alzheimer's affecting 6.2 million Americans, there's really nothing done to get out to promulgate that information that our lifestyle choices are hugely relevant as they are in diabetes and other metabolic problems in terms of our risk for these situations. The problem with Alzheimer's is we don't have a treatment for it at all. We have nothing that can reverse Alzheimer's disease as yet. So that really kind of, I think, lights a candle under us to really talk about, well, why is it happening in the first place, and how can we keep people from getting this disease that is not treatable? We recognize that at its root, at its core, Alzheimer's is a consequence of metabolic derangement. For example, if you become a type 2 diabetic, you have increased your risk for this disease, Alzheimer's, by as much as 4-fold. So that would tell you then that it's important to keep your blood sugar under control, not become insulin resistant, not become diabetic. We know there's a dramatic relationship between obesity and Alzheimer's risk, as there is with hypertension. And the answer then to your question is, so what is it about uric acid that would be interesting for me? And the interest was derived from the fact that uric acid isn't just something that we observe with hypertension and high blood sugar and diabetes and obesity. It is actually playing a causative role. For many years, we've said that, people with diabetes generally, you can expect the uric acid level might be elevated. We see high levels of uric acid in obesity. We thought, well, isn't that interesting, sort of as, a kind of a casual observation. But really interesting study was published in 2016 by collaborative researchers in Japan and Turkey. and it was called Uric Acid in Metabolic Syndrome, from Innocent Bystander to a Central Player. Meaning it doesn't just happen to be there. It didn't just happen to show up at the day the house caught on fire. It lit the fire. So it's playing a mechanistic role here, not just happening to be elevated. So now that we see this very powerful role of uric acid elevation is playing in metabolic issues, then we need to broaden our scope of understanding far away from just focusing on gout. Gout is the prototypic disease caused by elevated uric acid. Sure, I get that. That's how I learned about uric acid in medical school and residency. But the reality is that research correlating elevated uric acid to a variety of issues began in the late 1800s with a book published by a Dr. Alexander Haig, in which he explored the relationship of elevated uric acid to hypertension, to cognitive decline, depression, and even headaches, which he suffered from. And, we didn't really see much further after his research until around 2 decades ago, when there has been a virtual explosion around the world demonstrating how you can induce metabolic issues in laboratory animals by simply raising their uric acid, typically by giving them fructose. And in humans, you can do the same thing. And if you block uric acid production, even though they drank, 180 grams of fructose a day, that the metabolic consequences wouldn't appear. So we recognized from the human trials then that it's more than just an association, that these are not just correlative studies, they are causative. And that's been very exciting because we sure need as many tools in the toolbox as we can find, especially something as easy to control as uric acid. And, Brian, you're right that a lot of people aren't, talking about that. It's relatively new. But I think that, your podcast viewers are going to see that this is going to really be very exciting and take off over the next 5 years or so, that, uric acid is going to be top shelf along with measuring blood pressure, fasting blood sugar, and BMI. It's going to be a critical variable that we need to control to keep people metabolically intact.
That's interesting. And people love to have, some biomarkers to measure, some surrogate markers to understand, or not in this case, not even a surrogate marker, an important marker to understand what's happening with their health metabolically. And I think even more so, it can be more powerful when they really understand what's happening, what's going on, what it is that they're measuring, what it's doing. So maybe we can unpack uric acid a little bit. Like you said, we typically think of gout as sort of the uric acid problem, but we do know and have known for quite a while that it's related to metabolic dysfunction as well, like you said, obesity. So what is uric acid, first of all? And how does it get formed in the body? And then I guess we'll go in from there to how does it cause problems?
Well, uric acid is the end product of the degradation of only 3 things. So for everybody who's going to take the quiz, there are only 3 things. It's A, B, and C. And actually it's D, all the above. And that is fructose, the metabolism of fructose, the metabolism of alcohol, and the metabolism or breakdown of what are called purines. Purines are essentially the products of the breakdown of the DNA and RNA in the foods that we eat and even within our bodies when we exercise and break down muscle tissue. But the biggest player, without any doubt, these days is the elevation of uric acid as a consequence of our sugar consumption, fructose specifically. Glucose doesn't raise uric acid, but it can help actually produce more fructose in our bodies and therefore secondarily raise our uric acid. We'll talk about that later on. But I think that it's fructose. And when we see that 60 to 70% of packaged grocery store foods have added sweetener, of course, we would like that, right? We all like sweet. It gives us a sense that we're getting a lot of fructose in our diets and, kind of surreptitiously, we don't really know it. And we recognize that fruit juice and soda and, drinking these sodas is going to give us a sugar load, a fructose load, but it's hidden in so many foods by various kinds of deceptive names that we don't really recognize it as such. So, but fructose is the big player here. And yes, alcohol and purines are important, I would say until recently, but it's still going on. If you go online and look at diets to lower uric acid, they hardly ever mention fructose. And I don't want to begin to talk about why that would be. If you go to a major clinic website, for example, and try to read about how to lower uric acid, you'll see go on a low purine diet, maybe a mention of alcohol, but no mention of high fructose corn syrup that comes from the corn industry that is, supported by the government. So, I'm not going to get too controversial here, but I think it's fair to say that there are efforts to keep us away from recognizing fructose for the evil that it does render in our bodies. And those efforts are pervasive and underhanded. I'll leave it at that. But the point is that fructose is the player here. And, another perspective on this whole pathway that we're talking about, whereby elevation of uric acid signals the body to raise the blood pressure, increase body fat production, lock up body fat, rendering it less able to be metabolized, reduce cellular metabolism to preserve energy, raise blood glucose, increase risk of insulin resistance. Those are all great things. Becoming pre-diabetic and mildly hypertensive, gaining body fat. Those are all terrific ideas, great ideas for each and every one of your viewers if they will no longer have food for the next 4 or 5 months. So what I'm saying is that in the context of our Paleolithic ancestors, that this elevation of uric acid that they had as well was a powerful superpower, basically a powerful survival mechanism, because the consumption of fructose in the late summer and early fall would be a trigger for them to do those things, to raise their body fat, increase body fat, raise blood pressure as a hedge against allowing us to perfuse our organs even though we may be dehydrated, increase our glucose, increase our insulin resistance, to increase blood glucose to power the brain for 2 reasons: to avoid both starvation, so we could find food smart enough, and predation, so we're not food for somebody else. So these have been powerful survival mechanisms as an adaptation that really began about 15 million years ago in our very distant primate ancestors, when the Earth was cooler during the Middle Miocene period and food was scarce. And any selective advantage that an animal might have by virtue of his or her genetic variations that would cause more body fat production and storage would allow that animal to survive and reproduce. And what happened was there were a series of mutations in the genes that code for an enzyme called uricase. Obviously, that's an enzyme that would break down uric acid. These mutations rendered uricase basically useless. So these mutations led to a higher uric acid level, increasing body fat, increasing blood sugar, and these animals were the ones who survived and reproduced, and we are the descendants of those primates. Every human on the planet has inherited this uricase mutation, and it's the reason that your and my and every human that's walking the planet has a risk for higher uric acid, and our uric acid levels are 4 to 5-fold higher than those of other mammals who have active uricase and fully metabolize uricase to allantoin and excrete it. So uric acid is a signaling mechanism. It's screaming in the body, winter is coming. Make fat, store fat, downregulate mitochondrial function, increase inflammation, increase blood sugar, increase insulin resistance, and through a number of mechanisms that are really kind of interesting to explore. But these days, we don't have winter on the horizon. We're not going to be calorie deprived, and we keep stimulating that pathway every single day, increasing our body fat, responsible to some degree for the fact that, we have so many, 10.5% of our adult population has been diagnosed with type 2 diabetes. And we have about 88 million pre-diabetics in American adults. That's devastating. A third of Americans right now, adults, is obese. That's going to be 50% in 8 years, in 2030. 50% of American adults, not just overweight, but obese. So these are metabolic issues in and of themselves, but they set the stage for Alzheimer's, coronary artery disease, various forms of cancer, including breast, colon, and pancreatic cancer. Very, devastating problems down the line as a consequence of this metabolic destruction that is happening through the triggering of this uric acid pathway. The great news is that anybody can get a uric acid level done. You can go to your doctor, go to the lab. Many people have already had it checked last year in their annual blood work. You can go online and buy a uric acid monitor. I did. Here's my level, 4.7. So a finger stick, like many of us used to do before we had continuous glucose monitors, how we would check our blood sugar, nothing to it. And in this case, you only have to do it, once or twice a month. And the remedies are actually very straightforward. But again, I guess I went a long way in answering your question. The big issue is the fructose.
This is fascinating. So there's this evolutionary biology driven process where we lost this enzyme to break down uric acid over time. And now we have a lifestyle that sort of pushes uric acid production mainly through added sugar, like high fructose corn syrup and other forms of fructose, and sucrose, which is half fructose, added to foods in huge amounts that we were never exposed to before. And so that's driving this uric acid pathway, which then in turn, as you just eloquently described, is forcing the body to feel like it needs to go in storage mode, lockdown mode,
and it does. Look around. And this, our average uric acid level in 1920 in America was 3.5. Now it's 6. And that rise of uric acid has perfectly paralleled the increased consumption of fructose. So again, as Dr. Bland has told us over the years, food is information. And in this case, that fructose is informing us to that winter is coming, basically, that we need to prepare our bodies to survive a time of caloric scarcity. So, and that's the signaling pathway that's being activated each and every day in so many people. And when you look at it from that perspective of this evolutionary environmental mismatch, it very much explains what we see going on around us, in these times in terms of metabolic issues that, again, as I mentioned, set the stage for really bad stuff to happen. The good news is, though, this becomes now a very powerful tool in our toolboxes. We can easily measure our uric acid levels, and we can gain control over uric acid. So, step one is to identify the hidden sources of fructose, read labels, understand that clever people in the packaging and the marketing of foods change the name to this, that, and the other, whether it's organic cane syrup or whatever it may be, you can be sure it's fructose. Call it what it is or see what they call it. That's really important. Alcohol is important contextually because we know that hard alcohol will raise uric acid levels. We know that wine really, though it's alcohol, doesn't have much of an effect. But beer dramatically raises uric acid because it's not just alcohol, but beer is very rich in purines because it's made from brewer's yeast that has a lot of nucleic acid material. It's very cellular. When it's broken down, purines are formed, and those purines feed into the uric acid pool. So, the highest uric acid is seen in beer drinkers, and that is telling their bodies to make visceral fat, abdominal fat as well. So we understand where the beer belly is coming from. And it's interesting because, the messaging that we get in America is that we should be drinking low-calorie beer. It's not the carbs It's the purines and the alcohol that are making people fat. Japan is well aware of this, and they market purine-free beer because they're so dialed into the notion of elevation of uric acid. There's one interesting study that was published in in Japan, that followed a group of individuals for 8 years, and they looked at. It was a large group. They looked at 90,000 adults, 41 or 42,000 men, and 49,000 women. Followed them for 8 years, and the group that had the highest uric acid levels, over 7 milligrams per deciliter, their risk of death from all-cause mortality was increased by 16%. Their risk of cardiovascular death, dying from a heart event, was increased by 39%. Risk of stroke increased about 35%. And even more interesting was that with every point elevation above 7, the risk of, again, all-cause mortality, dying from anything, increased between 8 and 13% for every single point. So these are situations, the cardiovascular mortality, the stroke mortality, for which, disturbed metabolism is playing a really important role.
So the blood test, whether you do a finger prick test like you just showed, or you have a serum test in a lab done, there's oftentimes with lab tests, there's, a lab reference range, and then there's a more optimal range. Is that true with uric acid?
And I will tell you that a lot of healthcare providers would not have asked that question just now, because they would think that when the lab says normal range, that's it, end of story. And you know as well as I do that the normal range for fasting glucose is not the ideal or optimal range, right? We know that. I mean, they're telling you you're okay at a fasting glucose of 100. No, not so much. That's just because that's average. So, for people following you, they've learned that you're going to give them information that's not about being in the normal range. They can do better than that because you're giving them better information. They want to be optimal. The lab will tell you that the reference range, or the normal value, is anything below, at 7 milligrams per deciliter or below for uric acid. So the two things that are wrong with that are, number one, we don't want the normal or reference range. We want the optimal range, which is below 5.5, I might add. But also recognize that number is derived based upon a couple of factors. First, above 7 is when gout risk increases. It's a gout-based reference value. Number two, that above 7 is when we begin to see the precipitation of uric acid into crystals in the blood, which can then lodge in not just the joints, but also in the coronary arteries and even in the prostate. We can identify uric acid crystals. So what's best is below 5.5. Anything above 5.5, we begin to increase risk for cardiovascular disease. Uric acid directly acts, one of its mechanisms, by inhibiting the production within the blood vessel of nitric oxide. And that'll be on the quiz for all your viewers. Why does that matter? Well, we need nitric oxide because nitric oxide allows blood vessels to relax, and it keeps our blood pressure under control. When the blood vessel cannot relax and it's tight all the time, blood flow diminishes and blood pressure raises. It's the reason increasing nitric oxide is what is done for men who have erectile dysfunction. That's a blood supply issue. Giving a drug like sildenafil or Viagra allows more nitric oxide. The blood vessels expand or open up, and there's less problems with erectile dysfunction. Interestingly, elevation of uric acid is associated with a 38% increased risk of erectile dysfunction. Why? Because they have higher levels of uric acid. They're not activating nitric oxide as readily. They can't relax blood vessels and allow blood flow to allow erectile function. So we now are reviewing data from a month ago that just was published, looking at 6 million individuals and evaluating their risk for various diseases based upon drugs they're taking. and found a remarkable decreased risk. I think it was a 70% reduced risk of Alzheimer's in men taking Viagra. Think about that. So they improved their blood flow by allowing nitric oxide to do its job, and as such had a decreased risk for Alzheimer's, which has a huge vascular component. The brain needs blood. And the other thing that nitric oxide is really fundamental for is you need nitric oxide to allow insulin to make its way through the blood vessel and then make its way into the cell, so that the function of insulin is nitric oxide dependent. Uric acid elevation compromises that nitric oxide function and is therefore directly associated with insulin resistance, compromising the way that insulin works.
It's amazing. I mean, the connections are astounding, really. And it just, again, as we started this interview, it just makes it very apparent that this is something we all need to be paying very close attention to. So get your uric acid levels tested, get it under 5.5. So you mentioned fructose as the main driver. You've talked about alcohol and purines. In people who already have metabolic dysfunction, already have type 2 diabetes and high uric acid, and they've made dietary changes, they've sort of cut out added sugars and a lot of processed and refined carbohydrates and other foods, but they're still struggling with high uric acid. Is there another mechanism that's driving the high uric acid there?
And, nature developed this so that there was the best chance of making fat and raising blood sugar when that was a good thing. So this is a feed-forward process. And what happens in diabetics, the elevation of their blood sugar, is when blood glucose is elevated, as is going to be the case in the diabetic or even in the pre-diabetic, this activates something called the polyol pathway. And what the polyol pathway does is it transforms glucose into sorbitol into fructose. So here these people are totally off of fructose. They're not eating any fructose. They are teetotalers now, and they're not eating high purine foods. They're not eating liver and kidney and anchovies, and they're doing everything from a dietary perspective that we talk about, and yet they still have a high uric acid level. And if you were to be able to be measuring their fructose or even the enzymes that are involved in that polyol pathway, you would see that they are elevated, because that polyol pathway is driven by several things, one of which is law of mass action. Higher levels of glucose are going to force that pathway such that fructose is then created in the body endogenously, though you're not even consuming it. What happens to that fructose? It becomes uric acid. So there you go. These people have higher uric acids until such time as their blood sugars can be brought under control. So a lot has to happen. I think there's another area that we can explore that your viewers will probably be aware of. And it's another sinister way that this elevation of uric acid is threatening our metabolic health. And it has to do with what happens to AMP. As fructose is metabolized, the first step in the metabolism of fructose via the enzyme fructokinase is an ATP energy depleting step. So ATP is consumed when fructokinase is activated and fructose begins its path of metabolism. Ultimately, that ATP, adenosine triphosphate, is broken down to ADP, adenosine diphosphate, and ultimately to AMP, adenosine monophosphate. Now, what happens to that AMP? It can go one of two ways. It can be dealt with through the action of an enzyme called AMP kinase, AMPK. That might be a familiar area for many of your listeners, viewers. But so when AMP kinase is active, that's a good thing. AMP kinase helps us burn fat. It keeps our metabolic rate up. It reduces the formation of sugar in the liver called gluconeogenesis. That's really a good thing. So we really like AMP kinase to be activated, and that's one of the reasons we exercise. Exercise is a powerful activator of AMP kinase. It's how quercetin is helpful. Quercetin activates AMP kinase. It's where the drug metformin does its magic by activating AMPK, helping reduce this gluconeogenesis in the liver, so our blood sugars come down. That's why that's a diabetic drug. But it turns out that AMP kinase has an evil twin. And the evil twin goes by the name of AMP deaminase. And AMP deaminase does exactly the opposite. It increases lipogenesis, the creation of fat. It increases gluconeogenesis, the creation of sugar in the liver. Does all the bad things that we want to avoid. And as fate would have it, uric acid shuts down AMP kinase and activates the evil twin. So this is a really kind of a central theme here, a central player that we need to understand. And when you get that, when you understand that, gosh, we're doing everything we can to keep AMP kinase going because it keeps us lean and mean, gives us energy, our blood sugar stays under control. But now we're threatening that AMP kinase activity because of uric acid as a survival mechanism. It's really quite interesting. When you look at a bear who is foraging and getting ready, gaining body fat to prepare for hibernation, they virtually have totally shut down their AMP kinase. They are AMP deaminase full on. Make as much fat in the shortest period of time that we possibly can. Ratchet down metabolism as a mitochondrial dysfunction, threaten the electron transport chain, for crying out loud, and increase the production of glucose, increase gluconeogenesis. That's what the bear is like. When the bear then is hibernating, he or she is burning fat. AMP kinase then is active. But make no mistake about it, that uric acid is determining which of those twins is in control. And by all means, we want to do everything we can to keep AMP kinase lit up. And that includes keeping our uric acid levels where they need to be.
So I think of AMPK as, active in low energy states, and it's there to obviously cause the liberation of substrates for, fuel metabolism. And so that makes sense because uric acid would be stimulated in energy abundance, right? When we're eating a lot of fructose, when we're eating other things, it's, as you described it, it's sort of that signal that's preparing us to store energy, which means we get, insulin resistant and overweight and all these other things.
It's so fascinating. You can be sure I've told this story a few times before, but every time I recount it and work through that science, it's just breathtaking because, we've never really done this before, Brian. We've never really looked at how all these things are going on from an evolutionary point of view, how they were adaptive for us. And when you do that in this instance, and now we can apply that to so many other, why do we still have APOE4 alleles that increase our risk for Alzheimer's if they're making people get Alzheimer's and die? Wouldn't that have caused them to be maladaptive? Well, we know that it actually helps us with respect to inflammation, and turns out that people who have parasites actually have a reduced risk of Alzheimer's when they have the APOE4 allele. So to look at things through those perspectives, I think, well, why do we have these things? Why were they here? What's the upside? Is something we were never really trained to do, but it sure makes everything so much more interesting that, we're living with a body, a physiology that is ancient, I wrote my first paper on this topic a half century ago. Published it in 1971, probably before you were born, in the Miami Herald. And I concluded it was about this evolutionary environmental mismatch. And I concluded that by asking, what about us who are stuck with this outdated machinery, meaning basically the body and physiology that we have as a consequence of our genes? Well, we can't affect that, but we can affect the environment in this relationship between evolution and environment. We can affect the environment. We can change that side of the influence or the information that we're giving our bodies via the foods and other lifestyle issues and have a better outcome. I mean, that's the premise of the paleo movement, isn't it? That we're trying to emulate the environment of our Paleolithic ancestors because that's more in line with what our genome wants to see if it's to provide us better health.
Right, exactly. We lived much longer with that type of input, at least the theory, than certainly with the current input, over the last 100 years and certainly the last couple of decades.
Yeah, I mean, this is the statement that our Paleolithic ancestors, well, look, they had a really short lifespan. They couldn't have been healthy. No, as a matter of fact, they were absolutely robust. And, from their dentition on down, bone density, they were robust, strong individuals. They succumbed to infection. They succumbed to trauma. There weren't ERs. And so, the cumulative life expectancy, including, early life traumas and death and childbirth, et cetera, were significant, no question. But I would suggest that, you walk around, go to an airport when you're traveling and look at what American or people, globally look like now. And I wouldn't think the word robust would come to mind. I think we are frail and really metabolically compromised. We don't have good resilience against insults and onslaughts of various issues these days. We can't really respond appropriately. And, it doesn't take a lot to, knock over the house of cards these days. We don't have microbiome diversity like we used to have, and it begins there. And so, people tend to derogate the health of our Paleolithic ancestors, when in reality, they were very likely pretty darn healthy.
Yeah, we have like a very slowly waning mortality curve where, as the years pass, we, as you said, become more and more frail and sort of crawl to the grave, unfortunately. Most people anyway, or I would say that's the trend. And I think from everything that I've seen with our Paleolithic ancestors, it was more of a squared off, mortality curve.
That's right.
They sort of lived high quality or, whatever that meant at the time until they died. And I think, if you ask most people, that's what they would prefer. They would like to live their life to the very fullest until their last breath. And so, doing things like improving metabolic health and staying lean and fit and active and eating a good diet and taking care of the body, including having good uric acid levels, I think can stack the odds in your favor that you're going to have a better quality life until your last
You bet.
breath.
And, truth be known, our health lifespan has been declining now for the past 4 years. And when I say 4 years, that means 2 years prior to COVID. We know that COVID has certainly accelerated that, but the decline began happening pre-COVID. So we can't blame it on COVID. We are just, the metabolic health of people in developed countries is just so compromised. And COVID really brought that out as we saw who had higher risk of bad outcome, which makes sense when you think about the senescence of immune function and, how important that is for recoverability. And mitochondrial function being compromised by the virus without, the ability to engage things like mitophagy and then mitochondrial biogenesis that are compromised in people who are metabolically dysfunctional. So there's a lot to talk about. And what we've identified in drop acid is a new tool in the toolbox. It doesn't exist in isolation. It's along with exercise and, all the things that we've been talking about for a long time. But, this is very influential as it relates to your areas of interest, diabetes and, certainly obesity issues and hypertension issues, and interventional trials well conducted demonstrate that when you lower uric acid with gout drugs like allopurinol, you can drop weight and blood pressure just by lowering the uric acid. So, we can target that same enzyme that's involved in uric acid production that allopurinol targets, called xanthine oxidase. You can target that with quercetin or luteolin as bioflavonoids dramatically. I mean, there are interventional trials. One study, British Journal of Nutrition, 2016, looked at 22 males who had mild elevation of their uric acid, and they took 500 milligrams of quercetin, and in 8 weeks, they were able to drop their uric acid levels by about 8%. That's pretty significant. That was actually a 2015 study. But that's a pretty powerful drop in a very short period of time. And when you add to that then cutting out the purines and the certainly the added fructose, and being careful as to what type of alcohol you consume, I'm going to say that most people are going to readily get their uric acid levels under control.
So I'm just going to tease out some of the strategies that you've talked about, and maybe in the last few minutes here, we can just kind of bring all that together. So I think, you talked about definitely cutting out or cutting way down on fructose, and maybe we can talk about fruit here briefly. But before I do that, let me kind of wrap up some of the other bring together some of the other ideas. Beer is a bad idea because of the purines from the yeast.
I'm probably going to lose some friends on the beer thing, but there is purine-free beer now that's available. So there you go.
Okay, so we'll look for purine-free beer, and then lowering blood sugar, obviously important because of the polyol pathway.
One other thing as it relates to that pathway is it's very sensitive to serum sodium. So becoming dehydrated will activate the polyol pathway, and the serum sodium goes up. But that serum sodium is going to go up as well if you're parking your binge watching Bridgerton or whatever you're binge watching and eating bags of salted pretzels. Your sodium is going to go up a little bit, but it's enough that it's going to trigger that pathway. And interestingly, that is a pathway found in the brain as well, the conversion of glucose into fructose. And, what we know in the Alzheimer's brain, for example, is there's a lot of glucose floating around because it's not able to be utilized. Many areas of the brain are, in fact, such that they require insulin for utilization of glucose. So there is clearly activation of the polyol pathway such that fructose and the intermediate sorbitol are significantly increased in the Alzheimer's brain to the tune of 3 to 5 fold. So and uric acid is the downstream manifestation even in the brain, increasing inflammation. We know that neuroinflammation is central to the pathogenesis of Alzheimer's, increasing free radical mediated stress, and downregulating mitochondrial oxidative phosphorylation. So, gosh, this starts to paint a picture, doesn't it?
It really does. It really does. Now, I don't want to finish the interview without asking you about the high purine proteins, because this is something that's commonly recommended for an anti-gout diet, is to cut out these certain seafoods, red meat, and so forth, wild game. How much of an issue do you think that is?
I think they're less important. The reality is that 2/3 of the purines that are in your bloodstream are endogenous, coming from your day-to-day breakdown of your muscles and other tissues with activity, and certainly with exercise, and certainly with vigorous exercise, which will cause the next day's uric acid level to be elevated. That's why we talk about that. If you're going to check your uric acid, don't do it the day after a half marathon, because it's going to be elevated. But food then represents 1/3 of the purine pool. And the foods that you mentioned, the organ meats, liver and kidney, and certain seafoods like small fish, mackerel, anchovies, sardines, and things like scallops, shellfish, are higher in purines. It's not step one. You would be restrictive in those foods as a second line kind of intervention. The first thing is the fructose. So there are 5 things that are then to be considered. Number 1, fructose. Number 2, fructose. Number 3, fructose. Number 4, alcohol. Number 5, purines. So it's, for everybody, it's the fructose. Whether it's the fructose you're consuming, we've talked about the hidden sources, but also the fructose that you manufacture when your blood sugar is elevated by eating, processed carbohydrates, refined carbohydrates, and increasing your blood sugar, then activating this polyol pathway. Salt to be considered as well, because salt elevation activates that pathway as well, as does dehydration. Interestingly, what would be the value of activating uric acid if you're body thinks it's dehydrated. Well, there are a couple things that uric acid does. It raises the blood pressure by inhibiting the functionality of endothelial nitric oxide. So that'll help keep the organs perfused. But in addition, this uric acid elevation is going to stimulate, via its effect on the mitochondria, fat production and reduce metabolism. So you're going to store more body fat. Well, if you're dehydrated, why is that something you'd want to do? It's a great question. Well, when you burn body fat, you create carbon dioxide and metabolic water. So body fat is a way of storing a precursor to make water. That's why camels have a hump and can walk across the desert. It's full of fat. It's 80 pounds of fat in the camel's hump. So it's a hedge against death from dehydration for our ancestors. Now, of course, we don't need, we have water. We don't need to store body fat to make metabolic water.
Really interesting. Okay. And then what about fruit? So when you were describing this, I'm thinking that fruit is often consumed in the late summer months, and some people have described it as a signal to gain weight for the winter. Maybe that's a connection to the uric acid, but at the same time, there are a lot of health benefits of certain fruits. So
I think fruit is absolutely on the table. Eat fruit. Colorful fruit, eat colorful vegetables, you bet. Fruit consumption, by and large, according to the NHANES study, is not associated with elevation of uric acid. Why might that be? As mentioned earlier, the enzyme involved in uric acid production called xanthine oxidase can be inhibited by various bioflavonoids like quercetin and luteolin. And that's something you're going to get eating fruits and vegetables. Number two, fruit doesn't have a heck of a lot of fructose in it. An apple might have 5 grams. So there's not a huge amount of fructose like you'd find in fruit juice. And there's nothing natural about fruit juice. Our ancestors didn't stumble upon cartons of Tropicana growing from the trees, right? They ate the fruit. So if there's 5 grams in an apple, that's going to be fine. An apple a day does keep the doctor away. 5 apples a day, the doctor you will pay. So it's a question of, being reasonable and eating an apple or 2 a day. I do. Same thing with vegetables, though vegetables have even less fructose, so you can eat a lot of vegetables, and you should. The third thing that fruit and to a lesser extent vegetables have is vitamin C. And vitamin C is really effective as a uricosuric, meaning that it helps us excrete uric acid. So when you couple vitamin C with quercetin, and if you're going to take it as a supplement, I'd say 500 milligrams of vitamin C, 500 milligrams of quercetin, and then 100 milligrams of luteolin. That's pretty darn effective in terms of helping you excrete the uric acid and also helping you reduce the formation of uric acid in your body. And I would say that, are there people who ultimately are going to need a drug like allopurinol to keep their uric acid levels in check? Sure. I'm not going to tell anyone they shouldn't. But by all means, here are the tools, the keys to the kingdom on the front end to really gain control over uric acid. But most importantly, you have to know where it is. You have to get a level, a starting place, and then determine how your interventions are working.
Amazing. As always, Dr. David Perlmutter, thank you so much for sharing so much wisdom. I'm sure the book is available everywhere, Amazon and wherever you find books. It's called Drop Acid. If they want to learn more about your other work, what's the best hub?
Probably the best clearinghouse is drperlmutter.com, drperlmutter.com. There is a dedicated site for the book. It's dropacidbook.com. And people can learn more about the book there. But as you say, it's available at all the bookstores, Amazon included.
Okay, excellent. Thank you so much for, again, spending the time.
Thank you for having me. Great to see you again, by the way.
Great to see you too. Thank you.